Bismillahirrahmanirrahim. We are done from finding the component of a vector A on another vector B, and also we discussed the projection of a vector A onto another vector B. Also, we found the cosine or direction cosines and direction angles of a given vector. For today, we are going to speak about the physical interpretation of the dot product. Let's speak about the finding the work done by a constant force. The work done by a constant force is given by the value equal to F dot D, where the F is a constant force and D is just the displacement or the distance of moving object from one point to another point. So the work done can be given as dot product of the force and the displacement. To apply this, let's have one or two examples. Let's find the work done if the point at which the constant force F given by 4I plus 3J plus 5K is applied to an object moves from P1, the first point, which is 3, 1, and minus 2 to P2. That's 2, 4, and 6. Assume that the magnitude of F measured in newtons. And magnitude of D is measured in meters. Okay. We're going to find the work done by the constant force. Constant force, when we hear this word, constant force, F equal to 4I plus 3J 5K, it means that all the components are constant. 4, 3, 5. This is the meaning of the constant force. Because later on we are going to use non-constant force, which is function. The components will be function. In that case, we are going to use integration. But now, since F is a constant function, we will use the dot product. So I need to find the work done by the force applied to an object moves from B1 to B2. We have an object which is moved from B1 to B2. Which means that I have a vector here. B1 is the initial point, B2 is the terminal point. So to find the work done, which is F dot D, we have to find the vector D. The displacement vector D is equal to B1 to B2. And as we did before, to find the vector in this case, it is the terminal point minus the initial point. So D is equal to x2 minus x1, y2 minus y1, and z2 minus z1. This is equal to x2, this is 2 minus 3, 2 minus 3. y2 is 4, y1 is 1. And z2 is equal to 6 minus 2. This is equal to 2 minus 3 minus 1, 3 and 8. Or I can write it in, or using the standard basis, it is minus I plus 3j plus 8k. So this is D, and we have the constant force given there. So the work done the value is equal to F dot D. It is given by 4I plus 3j plus 5k dot D, which is minus I plus 3j plus 8k. This will give me 4. The first one, 4 with minus 1 will give me minus 4. This is A1 with P1, A2 with B2, A3 with B3. 3 times 3 is equal to 9. 5 times 8 equal to 24. That is 24. Sorry, it is 40. 5 times 8 is equal to 40. So minus 4 plus 9 is 5 plus 40 is equal to 45. So it is 45 newtons per meter or joule. So you have to think about the energy here, work done. So this is the idea of finding work done by a constant force moving from one point to another one. Let's take another example now. With that we have plug with weight the value is volt. Okay. Along a frictionless horizontal surface. by a constant force. F of magnitude 30 newtons. In the direction given by a vector D. A. What is the work done by the weight W? And this is the first part. We have an object block was moved in this direction. This is the D. It has weight. The weight is a force in or directed down. This is the weight. And we know that the weight is, or the direction of the weight is going down, but the direction of the D is horizontal. So the angle between D and the weight of the object is 90 degrees. They are perpendicular. Because it's mentioned then in the question, the surface is horizontal and the weight is directed down. Because the angle between, this is the weight, and this is D. Theta between them is 90 degrees, which means these are orthogonal. Weight and are orthogonal. So the work done in this case by W is equal to dot D. But this is equal to 0. There's no work done by the weight. Since they are perpendicular or orthogonal, their dot product equal to 0. So the weight makes no work. It has no effect on the energy needed to move the block from one point to another one. Now for the second one, B. What is the work done by the force F FD equal to 4 I plus 3j. In this case, the work done is equal to F dot D. But we don't have the vector F, we have the magnitude of F. So I have two ways to find the vector F. Either I will find the unit vector of D and then multiply it by the vector F, or we can use the other notation for the dot product. We know that the F product or dot product is equal to the magnitude of F multiplied by magnitude of D multiplied by cosine theta. Let's go back to the question. Say that F or constant force F of magnitude 30 meters in the direction given by vector D, in the same direction. So it's moving in the same direction of D. So F is moving in this direction also. Or it has this direction. F and D have the same direction, which means their angle is equal to, or the angle between them equal to 0. So since they are in the same direction, it's equal to 0. So the magnitude of F equal to 30 multiplied by the magnitude of D. Magnitude of D is equal to square root of 16 plus 9 multiplied by cosine of 0. This is 30 multiplied by magnitude of D, which is square root of 25 equal to 5 multiplied by 1. So the answer will be 150 Newton per meter, or Joule, 150 joules. So the work done by the force in this case will be 150. So this is one way to find the work done, which is F dot D. Another way is to find the vector F. We can do it. This will be another way. That F is equal to the magnitude of F multiplied by the unit vector of D, because it is in the same direction. That will be 30 multiplied by 1 over magnitude of F, that will be of D, multiplied by the vector D, which is 4I plus 3J. This is the vector F. Then we can use it to find the work done, which is work will be F dot D. That is 30 divided by 5 is equal to 6 multiplied by 4I plus 3J dot D, which is 4I plus 3J. And this will be 6 multiplied by 25, which is equal to 150. So another way to find the work, that is to find the vector F. by multiplying the magnitude of F with the unit vector of the displacement. Then apply the formula, W is equal to F dot D. That will give me the same answer, 150 joules.